Welcome to the Building with Metal podcast, presented by McElroy Metal. Whether you're a contractor, architect, designer, or building owner, we're here to help you build better with metal roofing and siding products.
What really makes paint last on a metal roof? Is it the paint formula, testing, or maybe the way it's applied? Well, stick with us because today we're going to unpack the science behind the paint on your metal roof. Hello, I'm your host, Kathy Miller, and today we're thrilled to be joined by Michael Lewis, Research and R&D Director at Sherwin-Williams. Welcome to the show, Michael.
Hi, thanks for having me, Kathy. And thank you for the brief introduction. Once again, my name is Michael Lewis, and I am currently the group leader for Sherwin-Williams Performance Coatings Group Building Products Division here in Bowling Green, Kentucky, one of several major manufacturing locations in the contiguous United States, as well as around the world.
Fabulous. So how many people are on your team there, Michael?
My particular team in my building products group, we're a little lean right now. I actually have three contributing chemists in the laboratory, but I am part of a broad network of formulating chemists and technical personnel here in Bowling Green, representing different areas of specialty, including color matching, including focus on manufactured products over building products type materials, as well as some very educated and knowledgeable resources that maintain their position here as staff chemists and advise in creative and informative ways on a variety of projects.
Fabulous. So I'm sure there is a lot of brain power at work in the building there for sure.
Yes, and it's a group effort.
I believe that. So how did you get into R&D, Michael, and especially in R&D in the paint world?
Well, I first became exposed to research labs in that particular type of workplace setting in university, where I worked as a student employee of a water quality lab. At that point in time, we didn't have all the nifty scientific instruments we have today, and much, if not all, of the water quality analyses were based around wet and gravimetric bench analyses. So that's where I got my hands on chemical reagents and glassware and just learned to function in the laboratory setting in general. But it was really when I entered the coatings world that I had the opportunity to become engaged with research and development. And it wasn't something I necessarily knew that I wanted to get into. After I graduated from university, I actually answered an ad in the newspaper. They were looking at that point in time for a development chemist here in Bowling Green under the Valspar sign. I literally had no idea what I was getting into. But it was in the manufacturing setting, of course, which was new to me. For any of us in industry or manufacturing, the workplaces and environments in which we work can be varied and interesting in their own way, obviously tailored to the type of products that we make. And in a general sense, I think as consumers, we would all be surprised to learn just how much goes into the development and production and manufacturing of every consumable product that we use in the United States and around the world. And that includes coatings. Coatings in general, most people think about house paint. They think about color swatches and the aesthetics. And we're concerned with all of those things too, but we bring something unique to the table in the pre-paint, post-form world, which is what makes coil coatings extremely unique.
And what is it that you feel like you bring to that world that's different, Michael?
Well, the small miracle that we accomplish, and this is the part that I find myself educating friends and colleagues outside the industry on first and foremost, is that we do apply our coatings on flat coils of sheet metal, and then downstream from that event, it's then formed into final products. And that might be appliances on the manufactured product side, refrigerators, HVAC units, air vents, all sorts of things like that. And obviously on the building product side, some of that can be trim coil, gutters and downspouts, where some of our good but base quality polyesters fit into the market. As well as silicone modified polyesters in the world of PVDF, which defines our most durable and aesthetically dynamic siding and rooftop coatings.
So, you mentioned spending a lot of time explaining what you do to friends and family. So does there tend to be one thing that kind of surprises them about your world? and what you do?
I guess it, and it was a surprise to me too when I first came into this industry, is the amount of physical strain and deformation that our coatings tolerate as a function of being pre-painted on flat steel. Until I think it's inconceivable that you could coat a flat sheet of metal in the very, very microscopic film thickness that we apply our coatings to, and still achieve color and gloss properties in a controllable way that sustains the aesthetic properties of that coating, as well as some of the deep draw stretches that the substrate itself, as well as the coating applied over it, are subject to. All the while, we maintain coating adhesion, excellent hardness, and again, the aesthetic properties of that coating, even as it tolerates the forming process in the end to form sometimes some very complex assemblies.
I remember the first time I was told the thickness of the film or the paint thickness on our metal, and I was absolutely blown away. Why don't you share with our listeners? Can you give them the actual thickness and then kind of give them an example of what that might look like, Michael?
Speaking in average measurements, because of course we have
Right.
a variety of products applied at different dry film thicknesses, but the average thickness of a human hair is roughly 100 microns, and our coatings are being applied at 20 microns, sometimes thinner. So roughly 1/5 of the thickness of a human hair is how thick the coating is once applied. And again, the small miracle being we can deliver consistent color properties, gloss or sheen properties with that coating, and sustain all of the sometimes challenging physical strains applied to the finished product in forming the final part. So it's not a stretch of the imagination to think that it requires a lot of focus on quality every step of the way to maintain those properties from the manufacturer all the way to its application and eventual installation in the field.
So let's pivot a little bit. I know that you also are responsible for teaching at the Sherwin-Williams Paint School. Tell us a little bit about that, your curriculum, attendees, just kind of an overview of it, if you would, Michael.
So Paint School is one of our flagship programs to inform and educate and help build relationships across the industry. We host that here at Sherwin and Bowling Green year-round with some exceptions. It runs once a month from January through May, and again from September through November. So we have some pockets of time we take off around holidays and some of the more travel-heavy times of the year. But the whole intention of the program is to grow awareness for individuals who may not have their hands on paint formulating as to what goes into paint formulas and their eventual performance criteria. Help make them sensitive to our end of the business and our expertise with what affects the performance of our coatings when applied and out in the field. It's a great course suitable for people from all walks of the industry. We do sometimes host formulators. A lot of times we're hosting sales and marketing individuals who are attached to our industry in some way and would like to learn more about the coatings and take away more of that knowledge and be able to speak more to what that brings to the table, obviously. We also host and see attendees from formers, coaters themselves, end users, basically every walk of the industry. And we really love the program because we can cultivate expertise and feedback from individuals in paint school that bring their own piece of the industry to the table, whether that's pain points that they'd like to learn more about, or just sharing some of their tricks of the trade that help get the best results out in the field when installing our products. The school is hosted by a panel of instructors, myself included, but part of the benefit to having a panel is that we bring different subject matter expertise to paint school, vis-a-vis formulators, folks from our technical service division, which are very coder focused, and they know a whole lot about how the paint gets applied and what those variables at the coating line are that affect the performance and results. And then lastly, we have a division of field investigators who sometimes respond to customer concerns in the field, but also give us that eyeball on what the field performance of our coatings is looking like out there in the field, and give us some really real-world feedback to weathering and durability and what they see out there.
And that's I'm glad you mentioned that. That's a fabulous point, right? It's one thing to think and test it in a lab environment, but it's a whole nother to see it out in a real world application with Mother Nature and all of
Absolutely.
that. So, yeah.
We'll probably talk about some of the testing we do a little later, but we do the best we can to forecast and mimic what Mother Nature does to our coatings, but nothing compares to the actual real world environment.
So we kind of build this episode as kind of getting into the science behind coatings. And so I kind of want to pivot to that a little bit, Michael. Let's kind of start with, for our listeners that maybe aren't chemists, or it's been a long time since maybe they had high school chemistry, what makes one type of paint formula last longer than another?
Well, I can't give you a simple answer to that because there's no one thing that makes a coating world-class or affects its performance criteria in a general way. Speaking in broad strokes, coatings are comprised of 4 families of ingredients. You have resin. Sometimes we refer to that as the vehicle or backbone. We have the pigment contributions to that formula, which in addition to providing us the aesthetic qualities we're looking for, specifically color, they also inflect on the durability of the coating, how UV resistant it may be long-term to deliver a variety of color fastness depending on the quality of coating applied. Solvent, of course, plays a huge part in our coating formulations. When we talk about polyester and silicone-modified polyester, these are essentially solvent-borne polyester coating systems. PVDF is in a league of its own. It's a very unique system, and it's functionally a thermoplastic that we disperse in a co-resin and some solvent to make it flowable for application on line so that we can apply it like any other solvent-borne paint. But the end result after cure gives you a very different structure and durability than standard polyester or silicone-modified polyester. PVDF is really our flagship right now for long-term durability and performance, and represents the state-of-the-art in coatings chemistry, providing a lot of that top-end expectation for color fastness and long-term durability in the field. And then lastly, we have additives as well as the 4th kind of family of ingredients. And additives do good things. Sometimes they do bad things, and that's where research and development gets involved, is finding out what doesn't work 9 times out of 10 until you latch onto your best performer or the solution that does work effectively. And additives can contribute to flow. They can contribute to the surface lubricity of the paint, which helps it form at roll formers without scratching, and any number of other concerns. It's an area we're always looking to find new tools to apply into our coatings. But we rely heavily on a number of tried and true additives that our basic building products platforms have been built around, with a lot of positive data supporting the performance. Originally, the PVDF chemistry and a lot of the fluorinated hydrocarbon technology stemmed from early research from DuPont. And so we've seen that affect multiple industries, and the major benefit to PVDF is the very fundamental strength of the carbon-fluorine bond from a chemical perspective. It's one of the strongest molecular bonds that we can engineer into a coating, and that's what makes it extremely robust as far as the field performance and its resistance to long-term degradation goes. When PVDF cures up, it actually forms somewhat of a crystalline structure to compose that coating, and in so doing, it encapsulates our pigments within that PVDF crystalline lattice, and that provides a protective shell for some of our vivid pigments. Really inflects on the superior color and to a fair degree gloss retention of PVDF coatings in the field as a result of that unique chemistry and the way the coating is formed upon cure. Resin chemistry itself is a very specialized segment of our industry. In speaking more in the polyester and silicone-modified polyester family of resins, these are basically engineered from their own realm of specialty. They have functional groups on them, and based on the way that they're cooked or reacted, They can be long linear polymers, excuse me. They can be shorter and more branched polymers. A long linear polymer is going to terminate in a reactive or functional group at each end of that molecular chain. And a more branched polymer is going to include reactive molecular branches across the length of that polymer. In general, the more branched a resin is, the shorter it will be. What it does, though, is it gives us a choice of how reactive a resin we're going to use and how those reaction sites interact with the other ingredients in the coating. As a general rule, a long linear polymer is going to yield a very flexible coating, and a shorter, more branched polymer and all of the potential it has to network with the other ingredients in the coating is going to provide you a harder surface. So in the most simple sense, in polymer chemistry, you could think of it as a sliding scale between flexibility and hardness with those given functional elements on the polymers. That being said, the buck doesn't stop with one polymer. We can effectively blend different polymers to combine functional elements based on the end use and the expectation of that coating's performance to try to bridge the gap between flexibility and hardness. Deliver something a little more hard or a little more flexible depending on the forming requirements at the out in the field and before install, obviously. That being said, the resin does determine the preponderance of the basic properties of the coating system as far as what kind of physical strain it can endure during the forming process, as well as what type or extent of long-term durability we can expect from it. And again, returning to PVDF, often its own bracket or category, we'll say, for the nature of the chemistry, once again described by the strength of that carbon-fluorine bond, much stronger than the hydrogen and carbon bonds that describe most of our polymers. To that degree, and the nature of it as a thermoplastic or a flowable solid give us that very robust film formation and the protective nature of the PVDF's crystalline lattice upon cure.
So without a doubt, there are lots of things at play to deliver the ultimate system that, to your point earlier, is about a fifth of the thickness, right, of a human hair. So absolutely crazy. So let's go ahead. You alluded to this a little bit earlier, Michael. Let's go ahead and pivot and talk a little bit about some testing. So when you guys are developing a new product, how do you ever begin to figure out how it's going to perform in 20, say, or even 30, 40 years?
Well, we sort of have, I would divide testing into two categories. Of course, we have the color and gloss properties, the aesthetic qualities of that coating. But as far as the durability and performance, we have the immediately perform. We have tests that we can perform immediately after coating, which are very practical tests to assess the coating's hardness, its flexibility, solvent resistance, which is also an indicator of the cure response of the coating to verify that we achieved full cure upon application. So these are very practical tests because they're, on the one hand, very simple criteria for us to meet in the field. Hardness is directly indicated by scratch resistance, so we can use more elaborate instruments, but we actually use mechanical pencil lead as a practical test for coating hardness based on the different grades of mechanical pencil lead grades. They're QC controlled for color, but they also grow in hardness up the scale as you graduate in the pencil rating. So that allows us a very easy to apply test when we're developing a coating, when we're running a product through our quality control department during the manufacturing process, at the coaters, and even out in the field. We can apply these tests in very short order with very simple tools to indicate that the coating has been cured properly and it meets the physical criteria stated on our technical data sheets for those immediate performance indicators. As far as testing for the long-term durability of a coating, in which case we would be talking about film integrity, or how long does the film continue to reside on the surface of the substrate after long-term environmental strain. That would also include resistance to fading and gloss loss, which is a factor of UV degradation as much or more than any other property. Although climatic factors such as acidity in the atmosphere or adjacency to a coastal environment could affect those criteria as well. And speaking of coastal environments, we have a battery of corrosion tests that we perform in-house in an accelerated fashion, which gives us very strong positive correlation to real-world performance to indicate, as much as anything, what that combined system is capable of, from the substrate to the pretreatment to the coating itself. How well is the coating performing as a barrier to water migration and corrosion of the underlying substrate? How effective are those corrosive mechanisms at deteriorating the coating system in general? So wherever possible, when we're developing a coating or possibly just modifying a coating or evaluating the influence of a brand new additive in the industry that promises to improve durability or gloss retention, then we can prepare representative samples in the lab setting and submit them to our partner groups in the industry to perform in-house testing using our Cleveland condensing humidity cabinets, salt spray cabinets. To a large degree, those short-term or accelerated tests are designed to be as stressful and harsh as they can be, so that we can get very strong indicators in a relative fashion to controlled variables to see how a new coating variable could perform in that setting. So in arriving at results, we will obviously always prepare a control sample to measure against, which would be representative of a proven coating formula or composition. And then we would compare any new iteration's performance against that coating in a relative sense to see if it's better than or worse than, given what criteria we're measuring, whether that was corrosion or color loss with UV exposure. To a fair degree, these accelerated tests are a good indicator of what we can expect for the long-term durability of the coating. But we know better. The real world is harsh, and obviously we do seek real-world exposure data to support coating performance with our existing product lines, and additionally assessing formula changes or innovations that we might be studying for the future. And to that end, we have a very large installation in Fort Myers, Florida, to which panels are submitted from around the world to subject them to a 45-degree angle of solar exposure as near to the equator as we can get here in the United States. In obviously a humid environment, being in South Florida. So what we've done is we've taken the opportunity to establish our test fence, in one of the most extreme solar exposure areas that we can establish. We have panels on the test fence that have been out and exposed for longer than 50 years. So we're still examining some really old product iterations for performance with opportunity. But in addition to that, we're constantly cycling test panels down to Fort Myers for them to benchmark on the fence, and then at given intervals, pull them and measure them for film integrity, color and gloss retention, and a test that we're performing consistent with our expectations, or that possibly an experimental effort is a negative way to go, or hopefully what we want to see is a positive way to go. But that's how we inform on our efforts in the research and development world to what the real world results are going to look like. We do have within our organization access to multiple test fences around the world to simulate other extreme climates, including coastal environments in both the northern and southern hemispheres. Salt, sea air or salt spray is different in a cold, damp environment than it is in a warm, damp environment. And we've done as much as possible to expand the network of access to test vents around the world so that we can better inform on our coating performance in various climates or environments that it may be installed.
Yeah, I will not. I'm always amazed when we talk about test fences. I've never visited one. It's always been on my list, and I need to get that done at some point. But the first time I understood that when a storm or a hurricane comes to Fort Myers, you guys literally go out and take off every clip off that panel, store them away from the storm, and then go put them right back on. It blew my mind the first time.
Amazing push of batten down the hatches.
Yeah.
The phrase goes. But yeah, we can have our very valuable exposure tests blown away with the first hurricane that hits the peninsula. So yeah, there's a lot of effort in firmly securing those panels to the test fence for normal circumstances, and then again being very conscientious about their management with extreme weather events.
So let's pivot a little bit. So you've got we talked a little bit about the lab and how the paints are formulated. Now we've talked a little bit about testing. But has there been a coating, Michael, that surprised you and your team, whether by poor performance or, by just knocking it out of the park?
There hasn't been any specific circumstance that I can really draw from to say that we were utterly gobsmacked by a test result with long-term exposure data. In part because our accelerated testing does give us a bit of a preview of what to anticipate there. There are opportunities for those data to diverge, and I know there have been occasions where formulators got excited about their short-term accelerated testing based on those early indicators. But then long-term exposure testing out in the field yielded a different result. So obviously we're trying to make real-world decisions effectively using accelerated tests, but the larger the magnitude of formula change or innovation that we're considering, the more deliberate, careful, and long track we'll make those exposure tests to make sure that we're delivering our customers formulas based on a robust set of data, carefully cultivated, considered before innovating any product.
Good point. So let's talk a little bit about that. What's changing most rapidly in the coatings technology field right now?
Well, right now, we've kind of seen the same type of coating technologies prevail in the field for a significant period of time. And there's nothing fundamentally wrong with that because collectively we've put some great coating technologies out there with very solid performance histories and expectations for their performance after installation today. I would pose that a lot of the innovations that we're seeing may be driven more from the environmental sector, where customers are more interested in a green composition, which is not a fair term because paint is composed of a number of materials that probably keep environmentalists up at night. That being said, when we properly apply a cured coating, it does represent a very stable product with very low potential to leach into the environment or contribute in any negative way to the local environment after installation. In manufacturing, in the application of these coatings, we do see some desire to move to ingredients and solvent packages that may be more environmentally friendly, particularly around the world where environmental restrictions and compliance regulations can vary significantly from country to country. They can even vary here in the United States from state to state, as we're aware. But globally, there are some countries with a much more progressive look towards restricting the raw materials that go into manufactured items and into coatings. So we've seen culturally a trend, and it affects more than just the coatings industry, but across products universally, public perception about forever chemicals, PTFE containing ingredients have kind of gotten a bad name as a result of some of the public health and environmental concerns that have been raised in a very general way, not targeting our industry in particular. But in response to that sensitivity, we have driven, in particular, our silicone modified polyester or Weather XL building products platform completely away from PTFE containing ingredients. And we were using one ingredient in particular to give us good surface lubricity through the forming process, which fits conventional wisdom about the role of PTFE in manufactured items. And just this year, we've been successful in, across the board, migrating away from the inclusion of that raw material in Weather XL altogether, having carefully researched an alternative that yields comparable performance without sacrificing anything that the old material gave us. So that would be one example of cultural shifts inflecting on our industry. And in addition to the solvent piece, where some solvents may be restricted in some countries, some it may be the purity or the byproducts that are resonant in a given solvent formulation by itself that cause alarm and extra consideration for our formulas. But across the board, I think the environmental push is to just do our best to reduce the hazardous air pollutants that result from solvent-borne products and coatings in particular.
That's exciting.
So we look for those opportunities, but we don't want to sacrifice product performance. So there's always a bit of a push-pull that's inherent to the challenge of driving the composition of our coatings to a little more environmentally friendly composition. That being said, where we're positioned today, technology-wise, delivers extremely durable, high-performance coatings, and we'll adhere to the toolbox of materials we have as long as it's appropriate for us to do so to meet the industry needs and also to address the needs of the public as they grow and change with time.
So, speaking of the needs and people's expectations changing, you guys have done fabulous things, obviously, with the warranties, right, and the performance of paint. I've been in the industry 30-some years, and when I first came in, we had 20-year warranties. And now we have 40-year warranties, 45-year warranties. Do you think we're at the max capacity for life expectancy as far as warranties, in that 45 to 50-year range, Michael, or do you feel like we'll continue to push?
I'm afraid to commit to that question because where we are today and some of the things we've accomplished, I'm sure would have made formulators and chemists shake their head or smile in wonder 30 years ago. Right. And even though where we are today with our platforms and technology, it feels like, man, we've accomplished so much. We can't possibly do better than this. I can't help but wonder what's next. And I feel pretty sure that the formulators of today would be equally surprised at the advancements we've made in the coming decades compared to the amount of innovation and platform improvement that we've seen previously. So
absolutely.
At this point in time, I can't imagine what's next, but it'll be exciting when it gets here.
I was going to say, but there will be something, right?
There will be some.
Yeah, no doubt. I think that's a very, very wise words on your part. So any advice before we wrap up today, Michael, what you would give to someone maybe that's specifying finishes for coastal environments or another harsh, maybe an industrial environment?
Yeah, well, the thing I would recommend is that when selecting a coating, the end use and the performance requirements of that installed part are the driver to coating selection. We need to know what the critical to quality criteria is and what's expected of this end use. And when we're talking about roofing materials and building siding, that's generally well understood, what kind of durability we expect to see from those coatings. But if we were cooking up a new application for a coil coating to an end use, the first question would be, what does this part need to do when it's formed? What do we need the paint to do? What kind of physical strains is it subjected to? Is it an interior or an exterior part? How worried do we need to be about that color stability over time, that film integrity over time? Obviously, we have different grades, good, better, and best, between our polyester, silicone modified polyester, and PVDF lines. We don't need to over-engineer the coating to the end use. We need the coating to be appropriate to the life expectancy and demands of the end use in particular. So what we need the paint to do as a formulator, that's always my first area of concern or inquiry. I might not just phrase it that way, but the more we learn about the eventual product that the paint is going on, the better informed we are on coating selection and how to marry the best properties from coating to substrate to pretreatment, which leads me to a point I want to emphasize. Delivering a world-class roof coating is not simply a function of the coating itself and the manufacturer of that coating, although we play a huge part in it. It requires excellence from every contributor in this industry, from raw material supply to deliver consistent, reliable performance with every raw material that goes into a coating, the proper formulation and application of pretreatments onto substrate at the coater line, the coater themselves, commitment to quality and observing the application properties at the time of coating. Are we reaching our peak metal temperature prescribed by the coating to yield the best results? Are we confirming positive physical results when coated before it gets any further down the food chain? How coils are stored and protected from moisture before they're formed into parts, as well as the transit and storage of formed parts in the field before installation. These are all very critical to getting the best performance of a coated system at the other end of the process as it's installed on a building, for example. And even those folks running coil through roll formers and then their careful handling during the installation process. The coating integrity must be maintained during the entire process in order to maintain the best protection to the underlying substrate and maintaining the properties that we expect to see. So it's really everyone who touches this process, again, from raw material to coating, formulation, application, and then the eventual field install. We all play a critical role in delivering a world-class result and a very durable result that everybody is pleased with for years to come out there in the field.
Absolutely, and I think that's very well said, Michael. I know we value our partnership with Sherwin extensively. We've been partners for, I think, over 2 decades now, and we can't imagine servicing our customers with anybody but you guys, and the knowledge and
That's awesome to hear, Kathy. Thank
wealth
you.
of experience that you guys bring to the table. And we talked earlier a little bit about how does a specifier know what type of system to use on a particular project, and we're resources. McElroy's a resource. Sherwin's a resource that we often bring to the table to those conversations if we need to. They're accessible to us to help to make sure, based on the environment, right, the building use, the life expectancy,
Absolutely.
all of those things you just mentioned, Michael. So
right, and we support positive relationships with every leg of the industry. McElroy being a model relationship between our organizations, and we're happy to inform with technical voice where it's called for, address questions as they pop up, and help each other succeed at the end of the day.
Well, thanks so much for joining us today, Michael. Is there anything else you feel like we need to share with our listeners before we wrap up?
No, we may have to have another session down the road. I feel like I had more to say.
We may have a version 2.0. How about that?
All right. Thank you very much for having me today and giving me the opportunity to speak about Sherwin-Williams Coatings and our partnership with McElroy Metal.
It's our pleasure, Michael. If anybody of our listeners want to connect with you or learn more about Sherwin, can you tell them how they should do that?
Absolutely. You can reach out to Sherwin-Williams through your normal sales contact if you have one, but feel free to look me up on LinkedIn. I don't have my actual credential listed there. I may be searchable through connections, but if anyone would care to email me directly, my email is michael.lewis2@sherwin.com.
Fabulous. Okay, thanks again, Michael.
Thank you, Kathy. Have a wonderful day.
You too.
Thanks for listening to the Building with Metal podcast, presented by McElroy Metal. To stay up to date with our latest episodes, be sure to subscribe wherever you get your podcasts. Visit us online at www.mcelroymetal.com for more info and products. Until next time, keep building with metal.